Yes.
Yeah. Yes, it's very much important for you to be able to understand. So in that kind of a scenario, make sure that in any metal that you're going to deal with, right, from sodium, aluminum, copper, iron, we have zinc, we have copper. Make sure that at least you know 2 to 3 ounces of sodium, 2 to 3 ounces of aluminum, 2 to 3 ounces of copper, those kind of things. Make sure that you're able, this should be the checklist. Describe the test for presence of sodium ions. Electrolytic extraction of sodium. You know, the extraction of sodium and aluminum, they are almost similar. You're aware about that? We are coming to that. But we are talking about that, and I think this one you did with Madam Amesi, that during extraction of sodium, we have the role of the diaphragm, the wood, the iron wall. We also have the steel wall, diaphragm. So we are talking about why do you have to add calcium chloride? What's the role of the diaphragm when you're extracting sodium? If somebody can remember, because I'm very sure that you went through the diagram.
Excuse me, Mwalimu.
Yes.
Madam Amisi here.
Yes.
I just wanted to clarify what points we covered.
Yeah.
So the 1, 2, 3, 1. We did 1, 2, 3 up to labeling the diagram, writing the equations. But now where the points to note from role of diaphragm, why is calcium chloride added, we did not cover.
Okay, perfect.
So
I think I can do that one.
If we start on that, from role of the diaphragm.
Yes. Very magnetic. Make sure that you just stay there. Don't sublime. Okay, that's perfect. I think we can, because you want to make sure that by the end of, Madam Amisi, the lesson takes how many hours? 1.5 hours.
It's 1:45, so you'll be able to cover. You may be able to cover 3 metals: sodium, aluminium, and the next one.
Okay, maybe sodium, aluminium, because of if today we are just probably maybe we can now try to finish up what remained, then we can go to aluminium. But if this time we can still go to copper, although I know it will be a little bit difficult to, but we'll see the way they are doing. So that by next time we can do, if today we finish this, we can do copper, and I can do copper and maybe zinc in the next episode. That's okay. Okay, now, student, I think you can just get this screenshot because you're not going to repeat it, because it's going to apply for even the other metals. That's very much important for you to be able to understand. But there's one thing that I want to tell you. When you're like, for example, dealing with the extraction of metal, except sodium, you'll find all the metals, the one of the pollution effect is that they lead to pollution, to environmental degradation. Because all the metals except sodium, they're extracted from the land. But you know, sodium, we only get the sodium chloride from the sea. So we really don't do a lot of digging. Although we also have the Chile salpeter, that one now we can now deal with extraction from the land. So that's okay. I think we can go to, I just want to use the diagram. That will be a little bit very easy for you to move. Okay, we have the oils of sodium. That one, Madam Amisi did with. So we look at now this one you did for confirmation of the metal ion in the O. Then now we go to, it is extracted through the down process, quick. Sodium extracted through the electrolysis of fused sodium chloride. What is it? Sorry. So these are something that may be, it may not have been captured, but these are some of the questions that the examiner nowadays will just try to extract something from the bush. Like now, you can be asked why we preferably use the rock salt and not the Chile salpeter or the trona during extraction of sodium. So the two main roles as captured on the screen is it is the most abundant and also require very little purification. You require very little purification with the oils of with sodium chloride. Very little purification that there, because just simply washing it to remove the mud and the small rocks. That's very much important for you to be able to understand. Yes, and okay, Pale. Are we okay there?
Yes.
Okay, or we talk about that. We have sodium chloride is fed into the down cell and it is strongly to melt it. A little calcium chloride is added to lower the melting point of sodium chloride from 801 to 600. That is simply to lower the melting point and also to lower the production cost. So that the role of, somebody will ask you, what the role of calcium chloride? It is added to lower the melt, and that is very key, to lower the melting point of sodium chloride. Very important. So when you're told to give the role of the calcium, don't say is to lower the melting point. You have to tell us the lower the melting point of what? If you're not able to remember the real melting point, you don't have to mention it if you're not sure, but just make sure that the keyword is to lower the melting point. Very important. This key, sorry. So make sure that you're able to capture that to lower the melting point of sodium chloride. That is very key for you to be able to understand. Now that helps to lower the fuel cost. Now, let's look at that diagram. That diagram is everything. It synchronizes everything that you can be able to get. Are you there?
Yes, sir.
Yes.
Yes. I want you to capture that. I want you to capture that that diagram. It is a very magnetic diagram that is going to summarize almost everything. So that the down cell that is used in the extraction of sodium, and you are looking at that. I would just want to explain that one very fast. Then we can be able to. I think I'll be even possibly be able to stop at that point. But looking at that, where the extraction of sodium. First of all, we have the fresh salt that is now fed into the down cell. Now, the electrolyte in the extraction of sodium is what? The electrolyte, students, what the electrolyte here? Are you getting me or am I talking to myself?
Fused sodium chloride and calcium chloride.
Very magnetic, very good, Griffin. That it was nani ametupea jibu, is it Griffin? Griffin ndiye alikuwa amenyua mkono. Is it Griffin? Anyway, so that's a common mistake that many students, when they are told to give out the O, they say it is molten sodium chloride. That is wrong. Should be molten sodium chloride and calcium chloride. It's a mixture. That's the electrolyte. And of course, we have already given the role of the electrolyte. Then in this diagram, you remember like this one already you did with Madam Amisi. At the cathode, we have the discharge of sodium ion, and the cathode, we have at the anode, we have the discharge of the chloride ions. Remember that during the extraction of this, during the extraction of this, when you have the molten sodium chloride, the sodium ions being the cation go to the cathode, while the chloride ions being the anions go to the anode. So when the sodium ions go to the cathode, which is the cathode is here, it does what? It gains electrons and forms the sodium metal, which is in the liquid state. The sodium metal once formed, it is less dense than the electrolyte, which is the mixture of sodium chloride and calcium chloride. So it rises on top of the electrolyte and is collected at the top there. You can be able to see the molten sodium being collected on this point. So then the chloride ions, move to the anode. The anode is here. Then they lose electron to form chlorine gas, which now the chlorine gas is now collected and directed out via the wood. And you can be able to see the wood is there. So it's to correct chlorine and direct it out. This chlorine is poisonous. So when you come to the pollution effect, you'll say that extraction of sodium leads to where are we having a lot of unnecessary noise? Why are we having that voice? I think is that notification of people joining. Now, we are having the chloride ions going to the anode, losing electrons, and now forming chlorine gas. The chlorine gas is collected and directed out by the wood, possibly to fume chamber. And if somebody asks to that, why now this one, which other industry should be located near this? This can also be manufacture of HCl, which uses chlorine as one of the raw materials. That is industrial manufacture of hydrochloric acid. Can be used, can be now, we can have hydrochloric acid manufacturing plant being collected there. Now, remember we're having the sodium being formed here. We're having the sodium being formed here at the cathode, and we have the chlorine being formed here at the anode. So there is a danger of the sodium ion and chloride ion mixing, or rather interacting. So that is why we now introduce the steel wire diaphragm. The role of the steel wire diaphragm is to prevent the sodium and chlorine gas formed from recombining at high temperature, which they are going to react violently. Are we together?
Yes.
Very good, very good, and very magnetic. Anyone, you have raised your hand, you're free to ask a question.
Excuse me, sir.
Yes.
Should the sodium at the cathode reaction be in solid state? The final product, should it be in solid state or molten?
It will be in a molten state. As you can be able to see, the sodium formed is in molten state. Of course, it is even less dense than the electron. That's why you see the direction here.
Yes.
From the cathode is being collected by a pipe and directed outside. We have now the collecting tank here, which will now collect the molten sodium. Are we together?
Yes, thank you.
Yes, but the chlorine collected here will probably be a gas, not in the standard site. Are we together?
Yes, we are. Thank you.
Very good, very good, very. That is a very valid question, very magnetic question. Yes, another one?
Excuse me, will you kindly repeat which industry should we look? Which industry?
Remember, good. When you talk about which industry is located near, remember you look at now, what is some of them, maybe the byproducts. Remember we're having, remember this is an industrial process. The main product here we are getting is what? What the role of down is to produce sodium, isn't it?
Yes.
Yeah.
But in the process of sodium, because the sodium we are obtaining it from the decomposition of sodium and sodium chloride, which is now we have the sodium ion and we have chloride ion. So as we are obtaining sodium, which is the main product, we also have chlorine gas. And the chlorine gas here will also be produced in large amounts because the sodium here, we are obtaining it in a large amount. So the chlorine gas will also be produced in large amounts, but it's not the product. It is a byproduct there. So this high amount of chlorine gas can also be used. Which industry uses chlorine as a raw material? And we have what? We have the what? We have the industrial manufacture of hydrochloric acid. So because it requires chlorine and hydrogen gas. So chlorine, this one, can be directed to the what? The industrial manufacture of hydrochloric acid, which requires chlorine gas in high amounts. Are we together?
Yes.
Perfect. Good. We can continue. Now, so now everybody now knows the role of why calcium chloride is added to lower the melting point of the sodium chloride from about 800 to around 600. That's the point. Then the iron wall feed with fire bricks here, unaona. So this cell is surrounded by iron wall that is surrounded by fire bricks. And what's the role of the iron wall? It's already written, just read. It do what?
To maintain height.
To maintain the high temperature so that the electrolyte does not solidify. Many books will say so that the electrolyte does not crystallize. But remember, really, crystallization is more of a when we are using solutions. But really, these are molten things. So I don't even know crystals. You need water. So I think the most important term there is that so that the electrolyte does not solidify. Madam Messi, are you there?
Mwalimu, I'm here.
Yes, I'm just talking about because that statement is captured in most of the publication that they say so that the electrolyte does not crystallize. And I think that using crystallization here is a misnomer by the virtue that we don't have water. These are not solutions. So I think that's correct. You agree we change that term to solidify instead of crystallize. I don't know.
Yeah, I'm in agreement because for crystallization, we'll need something like a saturated solution. So
Yes,
in this case, we have sodium chloride and calcium chloride in liquid state. They are not dissolved.
Exactly.
So when we cool the temperature, they'll change from liquid state to solid state. So it's correct to talk of solidify.
Yeah. So that's very much important, student, to get that because when you look at all the books, they have given that statement in a wrong manner. So that one should be treated as a fallacious misnomer. It's a wrong statement that has been repeated so many times that people think it's correct. So try to correct that one. You're going to find it in more of your books. So equation, the cathode and the anode, of course, this one I think Madam Amis, is anything you wanted to add from the diagram?
No, I think we are good. We are good.
Okay, perfect. Now, so we go to the electrolyte. We are just brushing off through there and make sure that the student, you have taken a screenshot of this.
Yeah.
Remember the diagram. This diagram summarizes everything, and it's very clear. Is clear, very clear about those things. So the equation, the cathode or the anode is captured there. Remember, at the cathode we have sodium gaining electron from sodium liquid. Molten sodium is less denser than the electrolyte, hence rises to the top of the cathode, where it is periodically removed. Whether the sodium formed is a solid state. I think that now, of course, I really explained that. I think that's okay. The cathode, the chloride ions are discharged to form chlorine gas, which escapes via the wood. Are we together?
Yes, we are.
And number two, by the way, very common mistake is that many students, I think most of the books, they have tried to balance these things. Wanawekea tu hapo, wanawekea tu hapo. So if you are told to write the equation that occurs at the cathode, don't try to balance the electrodes. Otherwise, you will be penalized for that. We don't balance the electrolyte unless, of course, maybe you are told why do you need to get through of this or that. So that one is not is not important. When you're told to write the equation, the cathode, just write the way I've written. Don't try to balance the electrode because from the rules of balancing equation, an electrolyte and an equation should be balanced using the simplest mole ratio. Unless they tell you to write the two of them, of which they'll direct you. But we'll discuss more about electrochemistry of when we have many ions later. The electrolyte is molten sodium chloride, high current of okay. So this one, of course, we already added. So this one should be the electrolyte is molten sodium chloride and calcium chloride. Should be the two of them. The electrolyte is molten sodium chloride, calcium chloride, but of course, high current of 30,000 amperes is passed through the electrolyte to decompose the O and maintain the ore in liquid state due to its resistance. So remember, these are some of the things that you are going to be finding, the examiner giving you. So somebody can even ask you, give the reason why we require a very high content, very high current is supplied during electrolysis of sodium chloride. And remember, this nitty-gritty detail, those small details that many students don't capture it. Like, for example, you saw a statement where I wrote why we preferably use the rock salt and not the Chile salpetra or the trona during the extraction of sodium. And maybe we are saying the most abundant and of course requires very little purification. Again, these are some of the information that may not be captured in most of the books. Why do you require very high current? Then the role of the current to decompose the ore and maintain it in liquid state. Chloride gas is liberated at the graphite anode, while molten sodium chloride is formed at the steel cathode. Also, somebody can also tell you why, name the materials from which the anode and the cathode is meant for, and make sure that you are able to capture that. Right? We are good? We are good, huh?
Yes.
Okay, good. We continue. Points to note. Graphite is the most suitable substance to be used at the anode because it is inert and does not react with chlorine gas, even at high temperature. Remember this one you cannot try you cannot try steel at the cathode, but graphite can be used at the anode. Graphite can still be used at the cathode. But now, if you use steel, which contains iron at the anode, it will react with chlorine at that high temperature. The role of the wood, it collects chlorine gas and channel it out where it is trying to prevent it from being released to the atmosphere, as it is poisonous and hazardous to the environment. That segment already captured when we'll be coming to the pollution effect. What are the main pollutants in extraction of sodium? And you're going to say that what are the environmental effects? The chlorine gas released, if not controlled, or rather if released to the atmosphere, or rather if it leaks, can lead to environmental pollution because it is poisonous. Are we together?
Yes.
Yes, good. Just still on that, because that is one of the things that is used a lot. Why is chlorine gas used as a weed killer?
Because of its bleaching properties. Because of its bleaching properties.
Because of bleaching properties, so what does it do?
It bleaches chlorophyll, so it prevents it from carrying out photosynthesis.
Perfect. That's very good. So when you chlorine, because of the bleaching agent, when it now it comes in contact with the leaves, it will bleach, it will destroy the chlorophyll. And when the chlorophyll is destroyed, the plants are not able to manufacture their own food, so they die. So those are some of the things that, of course, you need to capture it. Madam Amis, if you are there, just check if there is a kuna kijana, please. Our students, we have Emmanuel Kisa. Our Munanipata student.
Yes.
So yes. Whatever you're talking about, that, if you want to write a message, please write it in the main thing. There's a student mwenye alitaka kupata diagram na kusema, so alinitumia direct message. So andika tu, so that if his Madam Amisi is there, ataiona pia, and will be able to bring it to my attention. Also, one of the students, make sure that you remain unmuted so that when you read a message from somebody, you can maybe bring it up, that Mwalimu, just unmute if there's a serious issue, raise up your hand, tell me to. There's a student did not take this screenshot. So can you be able to get it? Sawa, those students maybe will join late, and that student not taking a screenshot. Tuko sawa, we are able to go now?
Yes.
Yeah, but remember this is the UPA Command Center. We provide you with the best. Now, Austin Nyaga, give any question?
Yes, I wanted to ask a possibility of calcium in the electrolyte to be collected in the cathode.
Yeah, I'm coming to that. I know that's an issue that maybe student will say, now that we still have now that we still have still sodium and calcium in the cathode, why is it that we are not going to discharge calcium? I think there's also that concept. Are we together?
Yes.
So I'm coming to that. I'm coming to that. So allow me to just go up, continue procedurally, so that finally I'll be able to capture that. Good. I'm answering that question. The rationale why we discharge sodium and not calcium. Now, we are having the steel wire diaphragm suspended between the cathode and the anode to prevent the sodium and chlorine gas formed from recombining at this high temperature. This one we had already captured it in the diagram. We are good to go. Sawa? That statement is clear.
Yes.
The steel cathode does not melt at its melting point is higher than that of sodium chloride and sodium metal. So that's it. You know, those are the questions that somebody will even be able to ask you. Why is it that now the steel cathode does not melt? Because its melting point is higher than that of sodium chloride and sodium metal. So it's able to be able to, the others, the sodium chloride and the sodium metal will be able to melt, but not the steel cathode. Calcium can also, that's now the point. Calcium can also, let me explain it so that I can give it. Calcium can also be discharged at the cathode. Remember at the cathode, because of we had calcium chloride and we add calcium at the cathode. Sorry. Remember at the I don't know why. At the cathode, sorry. At the cathode, sorry, I'm having a lot of problems. At the cathode, we have a calcium ion and sodium ion. Are we there?
Yes.
But now only calcium ions, only sodium ions are discharged. We are not talking about the calcium being discharged. Now, you have not done the deep electrolysis, but the deep content on electrolysis, on the preferential discharge. If you're going to go to Form 4, you'll be taught something called now, why whenever you have more than one cation, because all the cations will go to the cathode, why we discharge one and not the other. But I can just mention, one of the issue is the concentration. A more concentrated cation will be preferentially discharged as opposed to the one in lower concentration. So when you have two cations, the one that is in high concentration will be the one that will be discharged and not the other. Now, tell me, according to your wisdom, ukienda pale kwa down cell to make a calcium chloride, na ndo kuna sodium. Which one do you think is in higher concentration between sodium and potassium?
Sodium.
Tell me.
Sodium.
Sodium, why?
Sodium.
Why do you think is higher concentration?
Because the process is for extracting sodium and not calcium.
Exactly. The calcium chloride that is being added is simply just lead a little of it as an impurity, because the purpose of the calcium chloride is to simply lower the melting point as an impurity. The calcium chloride is the main thing. So we are adding more. In fact, it is a little calcium chloride is added, meaning that by the end of the thing, yes, calcium and sodium will go to the cathode, but it is sodium that will be preferentially discharged. So because sodium is in higher concentration than calcium. Tunaelewana?
Yes.
That point
Yes,
has sunk. Then there is another one that you're going to understand later. That one is we have the position of the ion in the electrochemical series. And we also have to find that now sodium is lower in the electrochemical series than calcium, therefore will be preferentially discharged. So you'll be able to understand. You'll be able to get that point. You'll also be able to get that point. Let me see if that thing is there. That statement is not captured there. So I think you better write it, that why sodium and not calcium is preferentially discharged at the cathode. Why sodium and not calcium is preferentially discharged at the cathode. Or in another word, it can also be why calcium is not discharged at the cathode. So those questions, they mean the same. Why calcium is not discharged, or rather, why sodium and not calcium is selectively discharged at the cathode. Have you written the question? Write it down so that it can give you the answers.
Pardon?
Why sodium is selectively discharged at the cathode and not calcium? Why? Give two reasons. Just read why sodium and not calcium is selectively discharged at the cathode. We are good. We are good to go.
Yes, sir.
Perfect. Good. Now, let's give the first question. The first answer nilisema ni gapi? Wale walikuwa nasikiza. What was the first answer?
Sodium is more concentrated than calcium.
Yes.
It is in a higher concentration.
Yes, sodium ions are in higher concentration than calcium ions. Don't say sodium. Sodium ions are in higher concentration than calcium ions. Good. Then point number 2, which you're going to understand later, is sodium is lower in the electrochemical series. Sodium is lower in the electrochemical series. Sodium is lower in the electrochemical series than calcium, and selectively discharged.
Pardon?
We are good. Tumesema sodium is lower in the electrochemical series than calcium ions, than calcium. Therefore, it is selectively, or rather preferentially discharged. You can use the word selectively, or rather preferentially, from the word preferred. You have got that point?
Yes.
That one you'll understand more will be during electrochemistry. For now, just understand the small bit that you can be able to capture. Now, Listen to this statement. Calcium can also be discharged the cathode. The calcium is separated from the, do you know at what point will calcium be discharged? Do you know? Or I can explain.
Explain.
Okay, let me explain. Oba kuna mtu akona idea. I want somebody to try, yes? So let me just explain. You see, Karene Kimutai, yes?
When all the sodium ions have been discharged.
Okay, when not all, but when most of the sodium is the electrolysis continues, the sodium ions start being discharged, up to a point that it reaches whereby, I think you have ever been given, we have seen those people who are given githeri. You know, githeri is a mixture of mains and beans. So kuna watu ukiwapea githeri, wanaanza kutoa tu mahindi peke yake ama wanaanza kutoa maharagwe peke yake. If those people start selecting the mahindi, it will reach a point, even if those things are on the same ratio, or rather, even if the maize, the maize grains in iron were more than the beans, it will reach a point, the beans now start appearing as if they are more than the other. Is that correct?
Yes.
You are given githeri. Iko na mahindi, iko na maharagwe. So when you start picking the maize, it reaches a point that the beans now look more than the maize grain. So that is the same scenario. We still have calcium and sodium. The sodium is in higher concentration. So sodium inaanza kutolewa, being discharged. The sodium ions are being removed. It reaches a point now, the calcium ions now they are in higher what? Concentration. At that point, now the calcium will be discharged irrespective of the fact that they are lower in the ECS. So calcium start being discharged when now its concentration rises. So what now they are discharged, you'll find that by the end of the process, you may have a mixture of sodium and calcium metal at the same place. Tunaelewana?
Yes.
Okay, now the examiner will ask you now, how will you separate sodium and calcium? And this is the answer, that the calcium has a higher melting point. So on cooling, it is solidified fast. Calcium has a higher melting point. So on cooling, it is solidified out fast. So ukianza to cool, the one that will become solid fast will be calcium. So you can pour out, you can easily, you know, when you put, just like when you put a solid and a liquid on the same place, the solid will go and will settle at the bottom, isn't it?
Yes.
Yes, so you can now separate it, either filtration or something like that. Calcium is denser than sodium. Again, if you place them in a container, sodium, even when they're liquid state, the calcium will always occupy that bottom layer and you can easily separate them. So those are the points that are very key. And because of time factor now, the role of the down iron wall, that one we gave, pollution effect associated with the extraction of sodium, formation of gullies. This one may not work, although it applies, but this only for the when you're using the Chile salpeter. So just talk about chlorine gas being poisonous and noise pollution due to heavy machinery. Those are the common one, the two that will apply to both of them. So this one, a formation of gullies, may not apply, especially when you're using trona and sodium chloride, which we normally obtain from the lakes. Tuko sawa?
Yes, Commander.
Yes. Yes.
So uses of sodium, just screenshot. There is nothing to explain there because of time factor. I wanted to now go to extraction of aluminum. Now, don't use those nodes you got in Form 2. Then, you know, in Form 2, we asked you the uses of alkali metals and their compounds. But here we are talking about uses of sodium. Don't start telling us sodium chloride is used as what? Talk about the sodium metal. Sodium is used in sodium prevalent. in the manufacture of sodium peroxide, which is used as a bleaching agent. Sodium cyanide used in extraction of gold. Molten sodium is used as a reducing agent in the extraction of titanium from its chloride. All those kind of things, make sure that you screenshot. Screenshot, eh?
Yes.
Yes.
Perfect.
Yes.
Advantages of downsell, also screenshot. Haya. Revision exercise, hiyo sitaki kushinda mambo yake, tushasema. Mambo yake, reason why. So now, guys, I want to give you the assignment. Those who have the octopus, you can use it, but now for now, just get it. Piga hiyo picha, the screenshot of the assignment. Ukipitia swali ya octopus, utakuwa umemalizana mambo ya sodium. Umepiga hiyo screenshot?
Yes.
Twende page 2. Angalia. Maswali za calculation hizo achana nazo, but utazielewa tukienda kwa electrochemistry. So, but just screenshot everything that can be tested. Are you through with that?
Yes.
Page 2. Can you go to page 3? Still on the same. Again. Bado hatujamaliza. Have you done screenshot?
Yes.
Finally, sorry. So those are the issue. We look at that, just one question. And by the time you finish that question, you have exhausted everything about that. All that question together with the answers are found in the octopus. And also book 4 other questions. While on book 4, just go and try to answer those questions. Let's now go to the next method. Siate tumemaliza. Naona majamaa wengine hapa wanataka ku. I remember this thing is this lesson. If you miss it or you came very late, it's also found in the YouTube. So you can be able to go and check that one from the YouTube. Can you go to extraction of aluminium?
electron.
Adamamisi, are you there ama ulienda?
These are things only girls solve.
Mwalimu, I'm here.
Kuna kitu ingine ya kuongeza ama now I think we are done with sodium. I think that's perfect.
Yeah, that's good. We move on.
Okay. Now we go to extraction of sodium. Aluminium, sorry. Again, we are looking at now the extraction of aluminium. We are going to look at the ores of aluminium, not sodium. Ores of aluminium and electrolytic extraction of aluminium. And then we go to uses of aluminium and pollution effect. So now, the checklist. Name these 2 ores of aluminium. Describe the test for presence of aluminium ions. Electrolytic extraction of aluminium through not the down cell, but the old cell. This one is just copied from the other one, but it's just almost the same. Label the diagram. Chloride, where chloride is added, and environmental effect of extraction of aluminium and the uses of aluminium. Now, we start by looking at this. The end of the lesson, you should be able to name the ores of aluminium, describe the extraction of aluminium. Now, we have the ores of aluminium. You can capture them. We have the bauxite, which is the cheap ore. That is now simply the hydrated aluminum oxide with 2 moles of water crystallization. Remember, this one is not really the formula of the ore, but it's the formula of the main component of the ore. Remember, the ore is not aluminum oxide. It is bauxite because it contains other impurities. So the only thing that the examiner will always ask you is write the formula of the main component of the ore. Tunaelewana, students? Don't confuse the two. Are you get the point? Eh?
Yes.
Don't confuse the two things there. Usijaribu kuzi confuse. The corundum is now the anhydrous, very dry aluminum oxide, which does not have water. And then we have the mica as captured there. So those are the 3 main ores. And you see, it's good to know the main ore, but many a time the examiner will come here and ask you, apart from bauxite, name 2 other ores of aluminum. You get it, eh? So it is important to understand all of them. But you see, these things are just the same. First of all, we start by confirming the presence of the O in the aluminum. This one is something that already we did. Of course, you have done qualitative analysis. You have done qualitative analysis. So how do you test for aluminum? First of all, this statement applies to all the old except the one for sodium. Crush the ore into a fine powder, add dilute nitric 5 acid into the powder, filter, then divide the filtrate into 3 portions. Remember, for all the olds, and let me tell you this, for all the olds, zote that you are going to find, for all the old that you're going to find, for all the old that you're going to find here, for all the old that you're going to find here, is that just you have to crush the ore into a fine powder, then you add dilute nitric acid in the powder, then you filter. That statement will apply for all of them, except for extraction of sodium. For sodium, we simply add water because all the salt of sodium are solid. So whether it's extraction of zinc, it's extraction of iron, lead, and you want to confirm the presence, you crush it into a fine powder, add dilute nitric acid because all nitrates are soluble, then you filter. Then now dividing will depend on which one. Divide the filtrate into 3 portions. The first portion, add sodium hydroxide. You get until in excess. Add the sodium hydroxide dropwise till in excess. For the marking, we just need to look at this like that. So the issue here, you'll get a white PPT soluble in excess. Then to the second portion, you add aqueous ammonia, dropwise until in excess. We put a white PPT insoluble in excess. That one now becomes it's either aluminum or let me just bog your mind. Or rather, if you add sodium hydroxide and put a white PPT soluble, what are you going to conclude?
Aluminum is present.
Not really. Sodium hydroxide, how many cations will form a white PPT soluble with the sodium hydroxide?
Calcium.
Calcium.
Lead, zinc, and aluminum.
Where is the note that I gave you? It is ZAP, zinc, aluminum, and lead. Sindio?
Yes.
Yeah.
Every class, mukona note, you pay a note of qualitative analysis. Sodium, when you add sodium, now part of white PPT is soluble. It is zinc, aluminum, lead. So now you cannot stop at that point. You have to go on and add another reagent, which is aqueous ammonia. Then aqueous ammonia will part of white PPT, which is insoluble in excess. So which one now you remain with what? You eliminate now zinc. You remain with
Aluminum.
aluminum and lead. So to differentiate lead and aluminum, you use either dilute HCl, dilute sulfuric acid, dilute sodium chloride, dilute sodium sulfate. So add end of that. Now that is the end. So in the exam, if you are told to describe the O, the marking point, you don't have to give out stories. You just tell us now, create the oil into a fine powder, add dilute acid, filter, divide the filter into 3 portions. To the first portion, add sodium hydroxide. The second portion, add aqueous ammonia. And to that portion, add any of either dilute HCl, sodium chloride, sulfuric acid, or sodium sulfate. It's something I want to give you. Just a summary. There's something I want to give you. 1 minute. The summary I want to give. A small summary. Just just 1 minute. I share something with you. Then we go back to where we had stopped. So get that. Are you there? Are you seeing the screenshot?
Yes.
Yes.
Yeah, this is the Octopath revision model for summarizing the test for an ion. And this one will be very useful. Even when you go to how do you confirm presence of lead, how do you confirm presence of iron, how do you confirm presence of copper, everything is captured here. So you see now, with this one, you can add sodium hydroxide to part of white PPT soluble. This is whereby you have zinc, aluminum, and lead. Then to differentiate the three, you add excess aqueous ammonia, white PPT soluble, itakuwa zinc. So if you are to confirm zinc, you simply divide it into, you just need one portion. That add nitric acid, filter, add nitric acid, crush the ore, add nitric acid, filter. To the filtrate, add aqueous ammonia. You get a white PPT soluble in excess. Zinc is the only cation that will form a white PPT, which is insoluble, which is soluble in excess aqueous ammonia. So to differentiate aluminum and lead, you can be able to see from here. To the third portion, add sodium chloride, add HCl, add sodium sulfate, end of that. So you can take a screenshot of this. It will become in handy when now you'll be now summarizing the test for even other cations. Have you taken a screenshot?
Yes.
Yes.
I will go back. Yeah. A lot of so now we are through with test for aluminum ion. Yes. Now, are you seeing my screen, by the way?
No.
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 Amuone kitu.
Napona wewe.
Yes.
Sahi bado amuone.
Bado.
No.
What about now?
Yeah.
Yeah, we can see it.
Oh, no.
We are good now to go?
Yes.
Perfect. Now, good. So now you can test for aluminum. We have said you crush the ore, divide it into, you crush the ore and nitric 5 acids so that you can now free the ions. That's the reason why you have to, you know, you cannot test for cations, you cannot test for ions as long as now they are not in solution form. So the rationale, you have to crush the ore. Why do you have to crush the ore into a fine powder? To increase the surface area. Then you want nitric 5 acid. to free the ions so that they can be tested. Now, when you have the filtrate, you divide it to 3 portions. Yes?
Just a minute. Let's mute. I think that sound was coming from Okwero Dennis. The rest, let's go mute. When you need to talk, you unmute. Thank you.
Okay, thank you, Madam Amisi. That I think you have been given the superior powers to mute all of them. Yeah, let me see. And I'm the host, so I can. Madam Amisi, uko wapi? Let me just first of all give you the superior powers because I can say you are not even, you are not. Madam Amisi, now you are co-host, just in case. Yeah.
Fine.
So now we are here, we have crushed the ore, we have now the role of crushing it to increase the surface area, where we need to first of all dissolve it in nitric acid to free the ion, so that now they can be tested. Remember, you start by adding sodium hydroxide, white PPT soluble, confirm, does not confirm, but that's possibility of 3 ions, zinc, aluminum, lead. So you have not yet confirmed whether there is aluminum. Then you have to now use elimination method of qualitative. The 3 ions, zinc, aluminum, lead, you add aqueous ammonia, you get white PPT insoluble in excess, which is now aluminum or lead. To differentiate aluminum and lead to the third portion, you add sodium sulfate, sodium chloride, or sulfuric acid. If you get a no white PPT, that's now aluminum. But you don't have to explain that one. In an examination setup, we just want to know the reagent and the steps, how you're going to add it. But it's good, you cannot answer this if you don't know how to carry out the qualitative analysis. So this question on confirming presence of ions boils down to understanding the concept of qualitative analysis. Now we go to the ores of aluminum. We had given this. So now, concentration and purification. How do you concentrate the ore? So now we go to the third step. This one is a little bit complex, but if it's broad, will still be given 3 marks. So I'll show you how to summarize it. Now we want to concentrate the ore. Once now you have obtained the ore and you're confirmed it is aluminum, now you have to increase the percentage of the aluminum in the ore. And now, first of all, you need to remove the impurities. All the ores, they say they contain other impurities. So we need to know, first of all, which are the impurities that are found in aluminum. You can just write impurities found in bauxite. 1, we have silica and iron 3 oxide. Those are the main ones, silica and iron 3 oxide. So we want to know, how do we go to remove them? So what we remove the impurities, we are going to concentrate to increase the concentration, the percentage of the aluminum oxide in the ore. So the role of this method, the concentration is to reduce, of course, to increase the concentration of the aluminum oxide in the ore. So the ore is first crushed and dissolved in concentrated sodium hydroxide. So aluminum oxide being apathetic dissolves in sodium hydroxide. Silicon 4 oxide being acidic will also dissolve. So by adding sodium hydroxide to the crushed ore, it dissolves 2 substances there. Silica, because it's acidic, and aluminum oxide, because it's apathetic. The iron 3 oxide does not dissolve in sodium hydroxide. So it is filtered out as a red mark. So I'll tell you how to summarize that. So we have said we are adding sodium hydroxide. The sodium hydroxide will dissolve aluminum oxide because it's apathetic, and also dissolve silica because it's acidic. Iron 3 oxide does not dissolve. So after adding sodium hydroxide filter, the filtrate will contain sodium silicate and sodium aluminate. but the residue is iron 3 oxide. So that one is removed. So the aluminum hydroxide is precipitated by either bubbling carbon 4 oxide into the solution or by adding pure aluminum hydroxide crystals. So the filtrate, you either bubble carbon 4 oxide or you add pure aluminum hydroxide crystals to precipitate now the aluminum hydroxide. Are we together?
Yes.
We'll summarize that. Note, the process of precipitating aluminum by adding pure aluminum crystals is called seeding. So when you are adding aluminum hydroxide crystal, that process is simply called seeding. Now, listen. There's something here I want to give. Sorry. Toka hapa. Ngoja kidogo tu, I just want to, I think I was using a different I wanted to, there is another one I had prepared, though that's why I wanted to get that. So that one is correct. Good. So yes, good. Now, these are summary. These are an October summary. That's what I was looking for. But I think you're able to see it?
Yes.
Good. Yes. So let me explain using now flowchart. So that becomes a little bit easy. So here we have bauxite, which has impurities, and the main impurity there are the aluminum oxide, and we have the aluminum oxide, and we have aluminum oxide, and we have silica. So we have the not iron 3 oxide, and we have silica. So those are the impurities that are there. So in that kind of a concept, we crush to increase the surface area. So now we have the powdered mixture. The powdered mixture now, we're adding hot concentrated sodium hydroxide. So now, this one now, when you down here, you need to say they must be filtering here. You need to filter. So here there is filtration. Here you can filter. You can filter here. You can say filter. So after you adding this one, you filter. So this filtering, you obtain iron 3 oxide as a residue, and sodium aluminate, a mixture of sodium aluminate and sodium silicate as filtrate. Then now you can add either carbon 4 oxide or aluminum hydroxide. When you're adding aluminum hydroxide, that one you call it seeding. Then you're going to get aluminum hydroxide. The aluminum hydroxide now is heated at a temperature of 100 degrees Celsius to form molten aluminum oxide, which is now taken for electrolysis. Are we together?
Yes.
Yes.
Now, listen. Yes. I think is the chat making you understanding a little bit easy?
Yes. Yes. Oh, yes.
So now listen. Yes. Kuna mtu anauliza swali, uliza. Is somebody asking a question?
Oh, excuse me, Chair.
Yes.
My question was on the addition of cryolite. They said to reduce to lower the melting point of the molten aluminum oxide, but in the LB they talk of it having a melting point of 2015 degrees Celsius, and in the top notch a melting point of 2030. I was asking if those figures are examinable. If you could clarify on.
That's why I'm saying
which one is.
Many books will have a little bit because things will vary. Of course, the melting point of a substance varies with even the pressure. Are you get the point? Whereby these things if it was done in China, if it was done in UK, the melting point and the boiling point varies. So the most important thing for you to be able to capture there is simply to say the role of, I'm coming there to lower the melting point of the cryolite, of the aluminum oxide. That would be the most suitable answer, because you find even most of the publication, and they are not wrong, is that they are picked this thing as from this point. Others are picked from the other point. And when you look at the range, is a little bit very, very different. So my advice is just be able to say that the role of calcium chloride is to lower the melting point of sodium chloride. The role of cryolite is to lower the melting point of aluminum oxide. Are we together?
Yes, thank you.
Yes, just capture it like that. The reason is now, even if you get water and you start boiling at where you are, everybody will get different boiling point because the difference in what? In pressure, atmospheric pressure, which also affect the melting point of the boiling point. That's why we're having those kind of things, because if somebody is writing a book as in China, we'll give us the melting point as for the atmospheric pressure in China, in the UK, in America, and all those kind of things, which are going to bring a lot of variations. Good. Now, we will come into electrolyzer, but first of all, now we are dealing with purification. Is everybody okay with purification now?
Yes.
I want to give you how you can summarize that thing in an exam setup. If you're told to simply describe the purification of the bauxite, can I give you how to answer it?
Yes.
Then you're given 3 marks. This is how you answer it. Crush the ore into a fine powder. Crush the ore into a fine powder. You have written that?
Yes.
Tick. Crush the ore into a fine powder. That's the starting point. Umemaliza hiyo?
Yes.
Yes, sir.
Add concentrated sodium hydroxide. Add concentrated sodium hydroxide to the crushed ore. Then filter. You can stir and filter. Add concentrated sodium chloride to the crushed ore. Then stir, filter. Filter to remove iron 3 oxide as residue. Yes, come in. After that, after filtering, you can now bubble carbon dioxide to the filtrate. Bubble carbon dioxide to the filtrate, or add pure aluminum hydroxide crystals. Bubble carbon dioxide to the filtrate, or add pure aluminum hydroxide crystals to the filtrate. Bubble carbon dioxide, or add pure aluminum hydroxide crystal to the filtrate to precipitate aluminum hydroxide. To precipitate aluminum hydroxide. to precipitate aluminum hydroxide. To precipitate aluminum hydroxide. Then heat the aluminum hydroxide. Heat the aluminum hydroxide strongly to obtain aluminum oxide. That now the purification ends there. That's now if you are told to give, you don't have to give all these scenarios. But remember, there are so many questions that can be brought here, including they can ask you when you filter, they can put it as X, they can tell you this is Y, then they'll tell you what is the composition of X. The residue is what? Aluminum hydroxide. They can tell you what the composition of Y. The Y is a mixture of sodium aluminate and sodium silicate. So there's a lot that can be captured there. And I think with this diagram, it makes your summarization, the summary of this thing very simple. Sawa?
Mwalimu, I request we take the roll call, please.
Yes, yes, you can.
I request we take the roll call. Boys, look at your screen. Pick your class, submit. $150, $160. That is 200. We have 30 more boys to take a roll call.
I cannot see the poll.
You have 5. You can't see the poll. This is who?
Maxwell.
Maxwell, you may need to update your application, but later, after class. Please update it.
Thank you.
If you can't see the poll, you update. And if you can't still, you cannot still see it, could be a version problem on that. But we have all your data. I just want to see those who are in class right now. 215 out of 235 there. About 15 boys. 219. 219, we still, 220, we still have around 18 boys.
And
223. It looks like others are not in class, mwalimu. Naona watu walikuwa wamelala. Wengine wameacha camera on wakaenda kutembea. We are at 225 now. 226.
Kwanza kuna class hapo inaitwa K.
K, yes, you can. K, only 20 are there, and even G, only 20 have responded. 228.
Congratulations, this is the D. D, they are doing very magnetic. And A.
D, this is excellent.
D and B, yeah.
Yeah. D at 34, this is very good.
And B.
Okay.
I think this one, you make sure that you share in the main wall for the teacher so that the class teachers can follow it up.
Yes, sir. Yes, sir. We are sharing with their parents also in their groups.
Okay, okay, good. That's good.
Okay. All right, I think we can end the poll now.
Yes, 98 to 98. We only have 3 students who have not done, and think that's okay. Yeah.
Great. Thank you so much, Mwalimu. You may go on.
Okay, thank you. Okay, good, perfect. I think now we are good to go. You can use this one simply the octopus methodology of revival, and it makes your work a little bit easy. So make sure that you are taking a screenshot of that.
Yes.
And remember, boys, you can even try to draw the chart later. You know, we are coming to the, you see, I've not talked about the electrolyte because that's where I'm coming from. So now from here, we are now going to electrolysis. Where now, when you have the aluminum oxide, now you can, now first of all, now take it to electrolysis because already heated. Now we can go to the next. So electrolysis of molten aluminum oxide. So we have obtained it, we have purified it, we have already removed the impurities. So the role of, remember the role of that process plays two main functions: to purify. Normally you are going to find some books, it's called the Bayer's process. It's called the Bayer's process, B-A-Y-E-R. Yes, Bayer's process, because it's now that process of purification. The role of it is to you remove the impurities and also you increase the concentration, the percentage of the O of the aluminum oxide. That's what you are doing. Now, we have now tested for the O, we are purified. Now we go to electrolysis. The aluminum oxide is heated until it melts. The aluminum oxide is melting point of about 1230. For this reason, it mixed with chloride, which lower the melting point from around 2000 to around 800. This helps lower the production cost. But I've just say the role of the chloride is to lower the melting point of aluminum oxide. That's the key word, to lower the melting point of aluminum oxide. High current of 1000 amperes are passed through the molten oxide to maintain it in molten state and decompose the ore. This is still the same thing, but you see now, I don't know whether who can remember the number of amperes we passed for sodium chloride? They were how many?
30,000.
30,000.
Yeah. But you see, this one is 100,000. Do you know the reason why?
It has a strong metallic.
Yeah, the aluminum oxide has a stronger metallic bond. You can see even now it has a very high melting point, about 2000, as compared to sodium chloride, which was about 800. So you see, for this one, to decompose it and to keep it molten state, you require even a higher amperes, high current, or rather higher quantity of electricity is required for this. Now you can see that's a simplified diagram of extraction of aluminum oxide. Sorry, that's a simplified diagram. You can see this the cathode is here, this the anode, and be very careful. Books like LB and other books, they make in your anode. This is wrong. If you label this one as the anode, that is wrong. This is not the anode. The anode must be these ones, the ones that are dipped in the electrolyte. That's the anode. Are we together?
Yes.
Yeah, and you can be able to see these electrolytes and this molten aluminum. We are coming to that to understand why it appears like that. Let's now go to the most comprehensive diagram. Look at that. So this one is summarizing most of the things that are needed. We have the ores, we have the bauxite. Bauxite is aluminum oxide. I don't know why it's not captured here, but of course you can just add it there. Bauxite is aluminum oxide with 2 moles of water crystallization. You have the corundum and we have the mica. Then we have purification. The step followed, we have the test for the aluminum, we have the purification, and we have the electrolysis. Those are the 3 main stages in extraction of aluminum. We have already done the first 2. So now we're in the 3rd one. So now, now you put the aluminum oxide here, you add chloride. The chloride lowers the melting point of the aluminum oxide. Then when that one happens now, in the anode, the aluminum cations will go to the cathode. The aluminum cation will go to the cathode, the cathode, which is there, the graphite cathode. We are going to have the aluminum there. So the aluminum gain 3 electrons to form aluminum liquid. Whereby at the anode, we are going to have the oxide ions going to the anode, losing electrons to form oxygen gas. Just like any other, when you have a melt, we have aluminum oxide here. So this aluminum oxide, it just decomposes to aluminum ions and oxide ions. So the aluminum ions, which are the cations, move to the cathode, gain electrons to form aluminum metal. The oxide ions go to the anode, lose electrons to form oxygen gas. Common mistakes that are found in most of the books, they try to balance the electrons. Napata wameandika 4 plus 12 electrons is equal to 4 aluminum. Hapa wamekuandikia 6 oxide ions. I don't know, 6 here. 6 oxide ions is equal to 3 oxygen gas plus 12 electrons. That is penalized. So if you're just told to write the equation that occurs in the cathode, just write this one. The simple equation. If you're told to write the equation that occurs in the anode, just write this one. Simple equation. But remember, for gases, you must use 2 ions. so that you're going to get oxygen gas, which is made up of 2 atoms. The same with chlorine gas. Now, there are some questions there that you need to understand. One, the aluminum formed is denser than the electrolyte. The aluminum formed is denser. For sodium, it was less dense, but this one is denser than the electrolyte. So it is settled at the bottom and is tapped out and collected, the molten aluminum. Once it's formed here, it is settled at the bottom. The electrolyte is molten aluminum oxide and chloride, which is less dense than aluminum. So it is the one that is on top. Number 2, you're going to be told, just like calcium chloride, which is added in extraction of sodium, there's another role. You can be told, name 2 roles of adding calcium chloride and chloride in extraction of sodium and aluminum. There are 2 things. They lower the melting point. For sodium, they lower the melting point of sodium chloride. For aluminum, they lower the melting point of aluminum oxide. That is one role, one main role. That's the main one. Then the other main reason why we add these other impurities in the normal chloride and calcium chloride is to improve the electrical conductivity of the electrolyte, to make it a better electrolyte, because we are adding the number of ions. And remember, we added the number of mobile ions. And electrical conductivity, electricity, or rather electricity is flow of current, and current is flow of charges. So the more we have more ions in the solution, in the electrolytes, the higher the electrical conductivity of that electrolyte. So these things, they play 2 roles: lower the melting point and also improve the electrical conductivity of the electrolyte. Tunaelewana, eh?
Yes.
Yes. Those are the 2 main things. So this one is very simple. Just make sure that when you're taught to label the anode, una label zile zimedip, easy. See, that one is wrong. Perfect. Now, aluminum foil remains at the bottom of the cell since it is denser than aluminum or molten aluminum oxide. The anode consists of carbon rods attached to copper clamps and suspended in a fused mass. They are arranged in such a way that they can be raised, lowered, or replaced when there is need. Listen. Unajua hii iko hapa juu is copper, but this one is graphite. Tunaelewana, eh? Are you getting the point, eh? Whatever is here, hiyo unaona iko hapo ya juu, hiyo clamp hiyo, that's copper. That's why we penalize you when you say that is the anode. So there are many that have manner the way you are saying, you can raise them. You can raise the anode can be raised or lowered. But remember, the oxygen gas formed at the anode can react with graphite. Graphite is carbon, it's very high temperature, to form what? Carbon 4 oxide. And that is why the anode had to be replaced from time to time. That's a question that you are going to be tested a lot. Even somebody can tell you, write 2 equations that occur at the anode. Tuko na hii, the automatic one. We also have the one for carbon plus oxygen to form carbon 4 oxide. And that already tells you now, the carbon 4 oxide, we also have carbon 2 oxide can also be formed there. In fact, somebody can tell you, write 3 equations that can occur at the electrode. Utaandika hii ya kwanza, uandike carbon plus oxygen equal to carbon 4 oxide, tena uandike carbon plus oxygen equal to carbon 2 oxide. And that tells you now the pollution effect. The release of carbon 4 oxide leads to global warming. And also carbon 2 oxide, which can also be released there, is highly poisonous. Then we have, because of the carbon reacting with oxygen high temperature to form carbon 4 oxide, this can lead to environmental pollution. Number 2, because of the carbon reacting with the graphite anode, the carbon rod is gradually wears out. It gradually wears out. So it has to be replaced from time to time because it is eaten away. Are you get the point?
Yes.
Good. So there's a lot of questions that can be asked there. That question we are going to find it why the graphite anode had to be replaced from time to time, because at high temperature, the graphite anode reacts with oxygen to form carbon dioxide. Then we go to the reaction the electrodes. You can be able to see the aluminum ions are discharged the cathode, forming aluminum metal, as you can be able to see still in liquid state. The oxide ions are discharged the anode, forming oxygen gas, period. That is direct. The oxygen form react with graphite anode due to high temperature, forming carbon dioxide or carbon dioxide. The anode wears away and should be replaced from time to time. Have you captured that?
Yes.
Good, perfect. Now, uses of aluminum used in making overhead electric cables due to its good electrical conductivity and also lightness. It's also used in making mirrors. It's also used to make paint. So those kind of things are very, very important. But there are some things that I want you to write using of aluminum. You can add these ones later on. That we remember there are those ones that I've given there, but there are some things that you're also going to be asked, like why you used to make cooking vessels or other fans. You can be asked why is it used to make cooking fans. You can be give a reason why aluminum is used to make cooking fans.
There's no share to.
First of all, it's a good conductor of heat. It is not easily corroded by cooking liquids because of the unreactive aluminum oxide coat. Remember, on exposure to air, aluminum forms aluminum oxide. This aluminum oxide is unreactive. So it does not react with the liquid that are being heated in that sulfur. So make sure that when you're told to give a reason why aluminum oxide is used to make cooking vessels, it is a good conductor of heat. That is very much important. It is not easily corroded by liquids that are being heated because of the aluminum oxide, which is unreactive. Are you getting the point?
Yes.
It is used to make overhead cables. I don't know whether they are there, whether it's captured. They use aluminum is used to make overhead cables because light and a good conductor of electricity. Light, we don't need a very heavy thing floating on top. And another one is a reducing agent damage process. In extraction of that one is root yes, so is a reducing agent damage process in extraction of elements such as chromium, such as iron, cobalt, manganese, those kind of things. So those kind of things are very much important for you to be able to understand. We also have corrodum. Corrodum, which is a natural oxide of aluminum. But that one is not a use of aluminum because that is that's now a compound of aluminum. But of course, it's also important to know that aluminum oxide, which is simply a natural oxide of aluminum, is used as abrasive. Is used as an abrasive, the corrodum. So, though the extraction of aluminum is efficient, it is generally expensive because the bauxite has to be purified. Large amount of electricity pressure used to maintain the ore in molten state. Carbon anode has to be replaced regularly. So you look down now why the extraction of aluminum is expensive. So these are things that sometimes they are needed. They are hidden in the books, but we always ask them. So make sure that you are able to capture those kind of things. Why that the extraction of aluminum is expensive because of what? You have seen the concept of purification, whereby you even require a temperature of 1000. So that's not very easy for you to be able to look at. Have you captured that information? Boys, have you captured that?
Yes. Yes, sir.
So we are winding up. So then we have the alloys of aluminum. The alloys of aluminum, we have the duralumin, which is made of aluminum, magnesium, copper, iron, and silicon, and silica, sorry. and that is silicon. Contain 95% aluminum, magnesium, and copper. It has a better quality than pure aluminum. Because somebody will tell you why aluminum is used to make, normally this is the one that we use to make aeroplane parts, because lighter. Don't say, the KLB will say duralumin is strong, with light. There's nothing like that. Because we talk about now, it is lighter. It is stronger. So those kind of things, it's lighter, it's stronger, it's more durable, and more resistant to corrosion than aluminum. So we normally use the duralumin. And remember, somebody will even ask you, state the components of duralumin. Those kind of questions nowadays you're going to be finding. Name the 4 components of duralumin, apart from, already you know duralumin is made of aluminum. So you're told, name 2 other metals that are found duralumin. So it contains magnesium, it contains copper, it contains iron, it contains silica. So you're going to be told why it's used to make aeroplane parts. Because it is lighter, it is stronger, it is more resistant to corrosion. Don't say it is light. Don't say it is strong. It is stronger. If you're told why, give the reason why we preferably use duralumin and not aluminum in preparation of aeroplane parts. And then that, I think I'm going to stop at that point. Make sure that you're able to get book 4, KLB. You can also get the top note. There is the octopus revision material there that associated with that. Before I close up, can somebody give us the pollution effect associated with the extraction of aluminum? Very fast. Somebody is asking, Jotham, yes, give us the reason.
Carbon dioxide causes the greenhouse effect.
Yeah, the carbon dioxide that can be released will bring about greenhouse effects. And there's also another one that I told you to apply for all methods, and that is what?
Environmental.
Environmental.
Land degradation.
And what?
Was it land degradation?
Yeah, will lead to land degradation due to the big holes and the gullies that are created there. That's very perfect for that. You can be able to get that. So you can see the answer there: formation of gullies, noise pollution, carbon dioxide produced causes global warming. Those are some of the issues. 2 reasons why duralumin is preferred in manufacture of aircraft parts. Can you give me the reason? Very fast.
Lighter. More
strong. Lighter, strong, and more perfect. Very, very magnetic. A white rocky material is suspect. A white rocky material is suspect to contain aluminum ions. Describe how you confirm presence of aluminum in the solid. And we have come to the end of our lesson today. Thank you for attendance on the lesson. And I hope you have enjoyed the lesson. It was very magnetic. That is all from the UPA Command Center, where the RCOH is the functional group. So anybody with a question, you can ask. We are ready to answer. I don't know. The next lesson started what time?
11.
Yeah. So in our next lesson, we'll be able to cover. We'll be able to cover copper and possibly zinc. Copper and zinc. I'll be able to navigate through that. That is on. Is it on Thursday? Yes, these metals are still on the YouTube. You can look at the channel, Thaddeus Mbaluka, the Ocean of Chemistry. You'll be able to get the analysis. So you can even prepare for extraction of copper, extraction of aluminum. They are there for those who came late. For those who never looked through extraction of sodium, I've already recorded those lessons are there. You can check them at your own time and see what you can be able to get. Otherwise, unless somebody has a question, or maybe somebody want to say something, then we can be able to get that. So then that's all. Madam Amisi, anything you want to add? Amo Shatoka.
Thank you so much, Mwalimu. Excellent work. Tumefurahia sana.
Okay, asante. Okay, have a good day.
Thank you for the lesson.
Thank you. Have a magnetic day.
Okay, good. Have a very, very